Welcome to the New Calculus channel. I am John Gabriel. In this YouTube video, which is titled Academic Ignorance and Stupidity Part 5, I shall be discussing two basic fields or two basic topics in mathematics, and the one is going to be the definition of complex numbers, and the other will be one of the hot topics that you see all over the internet, the topic on the fallacy that 0.999 is well defined as 1. So in this particular YouTube video I shall discuss both, and I'll start with the very first one, which is on complex numbers. And how did this come to be? Well, a lot of stupid people, mathematicians, began to think about what would happen if you had a negative under a square root. So I suppose you could start off in sensible mathematics and say that 1 is equal to the square root of 1 times 1. And you could proceed further to say that that is equal to the square root of minus 1 times minus 1. However, the step from here to here is invalid. Okay, it's invalid because this particular statement is only true if both A and B are greater than 0 or equal to 0. Okay, so this statement here is only true if both A and B are greater than or equal to 0. So this is obviously wrong. But watch what happens once you get past here. You can actually say that the square of the square root of minus 1, or what is now commonly known as I, is equal to minus 1. And you get a contradiction here. You get the contradiction that 1 is equal to minus 1. Well, moron academics will claim that after the third equal sign, which is this one here, okay, the operation is illegal, which, by the way, it is illegal. However, the irony is that you can't have complex numbers if this were not accepted as true. Okay, so if this is not true, you just don't have complex numbers. And how do I arrive at that? Well, think about it carefully. The only way you can get I is if you do what is done illegally after the third equal sign. In other words, supposing you have this, right? This here is actually equal to the square root of 9 times the square root of minus 1, presuming that you can do this sort of thing here, and you end up with the square root of 9, which is 3 times I. Okay, so you wouldn't have something like 3 times I if you weren't allowed to do that. So in this case here, it's illegal. Okay, it's illegal here. But in this case here, it's legal to do that. So this equal sign is exactly the same as this third equal sign over here. Can you guess who had a hand in this? His name starts with an E, followed by a U. That's right, Euler, the idiot mathematician Euler. Okay. Now, this also leads to a lot of other problems, because Euler wrote about the identity, which is hailed as something marvelous and wonderful, but it's actually a piece of junk. This identity here, I pi, is equal to minus 1. Of course, you know, when you produce ill-formed definitions like this, you have to start making all sorts of rules, just as they did here. For example, it's illegal to do this here, but it's legal to do it here. Okay. Now, watch what happens if we just apply simple algebra to this step over here. Well, couldn't we say that the log of minus 1 is equal to I pi? yes, I didn't have to write E there, but I'm writing it in to show you. This here is a total load of junk, okay? But this very identity implies this in standard algebra. So here's another thing you can't do any longer. I mean, you just can't proceed to the step here with this ill-formed definition. Okay. So there are some uses in doing this sort of thing. It enables you to prove theorems like the fundamental theorem of algebra a lot easier. But in my opinion, it's not required. In fact, it is a fact that it is not required. For example, if you have an equation, a cubic equation, right? It can have either one real root or two complex roots, or it can have three real roots. Okay? So these are the two possibilities in this case here. It can have one real and two complex roots, or three real roots, or even zero roots. No roots at all. Okay? Is this possible? Do you think it can have zero roots? Well, I doubt it. Because a cubic equation normally looks something like that, right? Well, it's bound to cross the x-axis at some point or other. So this isn't a possibility, right? It's not a possibility. So these are the only two possibilities here. It can have one real root and two complex roots, or three real roots. Having complex numbers in this situation enables us to say, well, since there are three roots and we have a complex conjugate pair, then this is the only possible scenario we can have. And this particular theory helps us to prove theorems like the fundamental theorem of algebra much easier than using any other method. However, this particular piece of junk here, where we have I squared is equal to -1, is completely irrelevant and not required in mathematics, not even in complex theory. The reason something like Fourier series works is that we have trigonometric identities that produce the results which we find useful. This here really plays no part. Okay, so when we write this, we know that we have this particular situation where there is a square root of -1. Of course, we can do nothing with it, but that's besides the point. What I'm trying to say in this video is that when you start off with ill-formed definitions, you end up with problems like this, contradictions, where it's legal in one spot and illegal in the other. Okay. And this is really what I wanted to talk to you about, the definition of complex numbers. Of course, a whole lot of theory has been built on this, and it's pretty shaky in my opinion, because the fundamental basis of complex numbers is not something that is well formed. It's put together without careful thought, just as a lot of mainstream mathematics is. Alright, so let's get rid of that and look at the second part of academic ignorance and stupidity. Let's just say new. We don't really want to save that. Okay, and let's go to this GeoGebra applet. Now you'll see over here that what I've done is I've created a parabola here with an altitude of 0.9 and also a diameter of 0.9, so that every time I move it, both the altitude and the diameter remain the same. In other words, in this case here it will be 0.09, in this case here it will be 0.9 and 0.9 across. This is the diameter. From here to here is the diameter, and this is the altitude. So if we move across, you'll see what happens. Okay. Eventually you end up with something completely illogical and something that doesn't make any sense whatsoever, because what is happening here is that you start off with the equation of this parabola, which is shown down here in this little red box, in this red font against gray background. And you'll see that this constant, which is minus 4.4444, etc., is the coefficient of x, okay, in vertex form. This is the vertex form of the parabola. But what happens to this coefficient as we increase n, or reduce the sequence, as you see over here, 0.9, 0.09, 0.009, etc., so that it becomes 0? What happens to that coefficient? Watch, it becomes very, very large, okay? And in fact, it becomes undefinable when x becomes 1. So the minute x becomes 1, we'll have this particular form of the parabola, where you've got f of x is equal to minus k times x minus 1 all squared, and k is no longer a number. So the point of this is that taking limits of this sequence here produces very strange results. Okay, the strange results imply that no parabola is possible when x is equal to 1, right? But in spite of this, moron academics will still say that it is a valid concept to take the limit of such a sequence and then replace it in a function. So for example, when you have something like this, s of n is equal to 1 minus 1 over 10 to the n, that actually generates these values, okay? Generates that, I think S1 is that, and then S2 is 0.99, and so on. And you'll see that the limit of the sequence is 1. But the sequence we're looking at with the parabolas is 0.9, 0.09. In other words, the difference each time between all of these terms, 0.09, etc. The limit of this sequence is 0. But if we replace it in the equation of the parabola, which is this, oops, I didn't mean to do that, which is that, we end up with this equation here and a constant of x squared that is undefined. Okay, so we can't just take the value of a limit and place it in a formula as you see over here. See, look what happens. So according to limit theory, this last term here, which is the altitude, will become 0. See, it will become 0 as I move. I've only done it up to 9 there because it makes no sense to go any further. You can see that it's impossible for this particular term here to become 0. All right. And yet this here is the very basis for the fallacy that says 0.999 ... is equal to 1. That's completely untrue. Okay, so if I find different ways, which I'm bound to because I'm constantly thinking about this nonsense, and one of my goals is to completely remove it from mathematics, along with the father of all mathematical cranks, George Cantor, I'll probably come up with many other proofs that are invalid. Incidentally, if you go to space-time and the universe, I already have many proofs that show this here is false, including all the main proofs. And so that's what I wanted to demonstrate in this particular YouTube video, those two topics, and I hope you've enjoyed it, and it will make you think about accepting ill-formed concepts, no matter who says them, and also make you question knowledge, even that knowledge which is supposedly established. Ask yourself, when does knowledge become untouchable? Does it ever? I don't think so. I think all knowledge is questionable, and no knowledge is ever past further investigation. All knowledge is subject to correction and revision. Bear those thoughts in mind as you think about what you've seen in this video. My name is John Gabriel, and this is a new calculus channel. See you next time.